Hello and welcome to screencast number 8 for Chapter 20, Conventional Energy Alternatives. So as you can see by this picture, we were talking about biofuels. So at this particular gas station, you can see the E85 that we were talking about that is made up of 85% ethanol and only 15% of the unleaded gasoline. And there's two other alternatives as well. There is a diesel, and you can see over here that this is your biodiesel that can be made, and that's what we're going to be talking about next is the biodiesel. We're first going to cover some corn-based methods, and then we're going to look into biodiesel engines. But biodiesel is really promising. So that's exciting. And then we're even going to consider even making gas out of algae. And that is a really novel idea for biofuels that are being developed. I'm going to ask that you please make sure that you read on page 572 and 573 the science behind the story, which assesses the EROI values of energy sources. That'll be important for you to read. Okay, let's get started. So ethanol is not our most sustainable energy choice. There's some problems with using ethanol, and let's discuss those reasons. There is enthusiasm for corn-based ethanol in the United States. Policymakers do not widely share the concerns with environmental scientists. They believe that the corn produced from the ethanol exerts considerable impacts on the ecosystems. These are the environmental scientists that I'm talking about. This is what they believe. And they look at it as saying, well, you've got to have pesticide use, which we know pesticides can run off and cause algal blooms. Not pesticides, fertilizers. Pesticides are also going to run into the water systems and make the water systems toxic like DDT did. Fertilizer use is what I was talking about, going to cause the algal blooms. There's going to be freshwater depletion because you're going to have to water these crops. And there are other consequences of the monocultural industrialized agriculture. Corn ethanol crops take up precious land. This precious land could be used to just be natural habitats, or it can be developed for other purposes. If we were to try to produce all the automotive fuel currently used in the United States with ethanol from U.S. corn, the nation would need to expand its already immense corn acreage by more than 4 times. So it would take so much more land in order to produce this. Ethanol already competes with our food production, and it actually drives up our food prices about 40%. It drives it up. The U.S. corn crop today is used to make, not all of the corn crop, but about 40% of the corn crop is also used to make ethanol. And byproducts from ethanol production are used in livestock feed, and this accounts for about 28% of the U.S. corn crop, and it goes solely towards that ethanol. Farmers have shifted more corn crops to ethanol. Corn supplies for food have dropped. It's caused skyrocketing prices in 2008, which made it very difficult for poor to afford the food. There were protests and riots that ensued in many of the nations. You could understand this with Mexicans, whose corn tortillas are the emblematic type of food for their national cuisine, and working class citizens found themselves struggling to buy their food staple. In 2012, the U.S. experienced a drought and corn production went down. International leaders urged the United States to cut back on its ethanol production so that it would free up more corn for export to the nations in need of the food. So there were some definite problems that existed with that. Corn for ethanol use also requires substantial inputs of fossil fuel. So think about operating farm equipment. You know, you've got your tractors and I don't know all different kinds of farm equipment, I'm sorry, but you have that equipment that you need to use. Making petroleum-based pesticides is going to be necessary, the fertilizers. You'd also need to be able to transport the corn to the processing plants, and the water in the refineries need to be distilled as well, and that causes the use of energy. So simply shifting from gasoline to corn ethanol for our transportation needs would not eliminate our reliance on fossil fuels. Corn ethanol yields only modest amount of energy relative to the energy that it needs to be inputted. So the EROI for this is like a 1.3 to 1 ratio that we see. So that's really small. That only means that we gain like 1.3 units of energy from ethanol, and we need to expend 1 unit of energy. So it really isn't cost effective. The Brazilian baggies ethanol is considerably higher, but extremely low ratio for corn ethanol makes this fuel inefficient. So many critics do not view corn ethanol as an effective path to sustainability. Okay, let's take a look at biodiesel power that powers diesel engines. And biodiesel is fuel that is produced actually from vegetable oil. It's used in cooking grease or it's animal fat. And the oil or the fat is mixed with small amounts of ethanol or methanol, which is wood alcohol, in the presence of a chemical catalyst. Europe, where most biodiesel is used, comes from rapeseed oil, and the U.S. biodiesel produces come from soybean. Vehicles with diesel engines can run on 100% biodiesel, and biodiesel can be mixed with conventional petroleum or petrodiesel. There is a 20% biodiesel mix called B20 that we saw in the picture that is in common use today, and this cuts down on the emissions compared with the petrodiesel. It's non-toxic and it's biodegradable. The fuel economy is almost as good, and it just costs a little bit more. Numbers of people are fueling their cars with biodiesel from waste oils. Buses are recycling, trucks are now using diesel, and many states and federal fleets are using biodiesel blends as well. As far as the production of it, eliminate it, what we can do, and before I talk about production, some enthusiasts are even going a little bit further, where they're eliminating one of the process steps that biodiesel requires, and they're using straight vegetable oil in their diesel engines. Now this requires a little bit of modification to the engine, but it can run on it. And using waste oil and biofuel is sustainable, but most biodiesel today, like most ethanol, comes from crops grown specifically for that purpose. These crops have environmental impacts similar to what we've already discussed. Growing soybeans in Brazil and oil palms in Southeast Asia hastens the loss of tropical rainforest. And growing soybeans in the United States and rapeseed in Europe takes up very large areas of land as well. So major crops grown for biodiesel and for ethanol exert heavy impacts on the land, farmers, and agriculture. So scientists are experimenting with a variety of other crops like wheat or sorghum, even sugar beets, hemp, and some different kinds of grasses to see if they could better provide the energy. The next idea that I'd like to discuss, I'm very excited about and has a lot of potential. And these are considered novel biofuels that are being developed. And algae. Algae is one of the promising next generation biofuel crops. Uh, we know algae is green pond scum. There's several different species. They're all photosynthetic organisms, and they really produce a large amount of lipids that can be converted into biodiesel. So alternatively, along with this, the carbohydrates that are in the algae can also be fermented to create ethanol. So you can get a 2-for-1 with this. And as a matter of fact, there's a variety of fuels, including jet fuel, that can be produced from algae. Algae can be grown almost anywhere in open ponds. I don't know if you're aware, but they have ponds around raceways. They call them raceway ponds, and they are used around the racetracks. They're used there, I think, more for protection in case that there was an accident or anything or a fire. They've got a water source to put out the cars that are on fire. So they circulate around this racetrack, and algae can grow in them. There's more controlled and intensive production that can achieve in tanks or in closed transparent tubes called photobioreactors. And algae grows really fast, faster than most terrestrial crops. It can be harvested every few days. It produces much more oil than other biofuel crops do. And algae farms can use all kinds of water. They can use wastewater and ocean water and saline water. Algae doesn't care. It uses the nutrients that are in that water. So let's go back to our wastewater treatment facility. They could grow algae in the treatment plant because they have all that water, and they could sell that off to be used as a biofuel. Another thing, because we can pipe in carbon dioxide into the water, here's another way of using carbon dioxide, and that's going to speed up their growth. And algae can make use of smokestack emissions. Again, that's going to speed up their growth. So placing algae farms next to power plants as a source of carbon capture is a promising combination. Producing biofuels from algae right now is very, very expensive, so that's one of the downsides to this. There are private sector people that have been investing and helping to keep the cost down. If we rely on any monoculture crop for energy, it may not be a sustainable strategy. So looking for this algae is another a good idea. Another type of substance that we could use is cellulose. Cellulose gives structure to all plant material. It has really no food value for people. It's abundant, and we're looking at using cellulose to produce cellulosic ethanol. This ethanol can be made from the low valuable crop waste and residues from corn stalks and husks rather than from the high value crops. So there's certain plants that hold promise specifically for the cellulosic ethanol. Switchgrass we've talked about before, which grows on in the prairies, and that if we manage that right, it could provide wildlife habitat while serving as a crop. And if it's planted with polyculture and mixed with other species, it could be very abundant. All right, we're going to end this here, and we'll see you on the other side.